am now going to talk about requirement number 6, how to develop and maintain secured systems and applications. Now 6.1 states establishing a process to identify security vulnerabilities using reputable outside sources for securing vulnerability information and assigning a risk ranking, for example as high, medium, or low, to newly discovered vulnerabilities. What this means is when you're using a reputable establishing a process so basically the whole take from this is establishing a process to identify security vulnerabilities, either high, medium, or low. Now this can include the CVSS base score. It doesn't have to. You can use something different. Basically what that is you do a vulnerability scan, and if you're using something like Qualys, for example, it'll scan it. It will display medium, high, or low, and then you could click on the link that'll take you to the CVSS page as seeing what that vulnerability is and what it's about and why is it high, medium, or low. Now, ranking it might show high, and it might show depending on your environment. Let's say you're in an environment and it's ranking high, but if you change it, your environment will not work as intended. Well, if that's the case, then you'll need to implement something else that will help mitigate any attacks from that vulnerability from being high. Or maybe it's showing high, but technically it's not. Maybe it's a medium. But you'll have to get with the system admin and go from that system's owner. Ranking should at minimum identify high risk. What that means is you could identify medium and low as well, but as long as you're identifying high risk, that's what's most important. Intent is to keep up to date with new vulnerabilities. As when I read that, when I was started rethinking the whole process of establishing process to identify vulnerabilities, and then I reread 6.1 again. And then it says using reputable outside sources for security vulnerability information. And I was like, the intent is to keep up to date with new vulnerabilities. So this tells me that 6.1 is telling me to make sure that these people have some kind of procedure to go out and say, hey, we're going to look for vulnerabilities based on any updated vulnerabilities on a daily basis to see if this is going to affect our systems or not. That's basically what 6.1 is all about. This is not, and then the second one says, this is not achieved by a ASV scan or internal vulnerability scan. This requires actively monitoring industry sources, which incorporates the intent to keep up to date. So I was misreading this at first when I first saw it. I thought it was like, scan it, make sure you list the high and low, whatever, on a spreadsheet or something like that, right? What it's actually talking about is going to a site, making sure you're up to date with vulnerabilities pertaining to your environment, not running scans. And I was like, oh, okay, that makes interesting sense. Ensure that all system components and software are protected from known vulnerabilities by installing application vendor supplied security patches. Install critical security patches within 1 month of release. Oh, I should have highlighted 1 month as green there. So basically you want to install critical vendor supply for security patches within 1 month of release. So the biggest takeaway from this slide is critical releases, make sure they're installed in 1 month. Non-critical releases, make sure they're installed within 3 months. That's biggest takeaway from this one: to protect the components from known vulnerabilities. Develop internal and external software applications, including web-based administrative access to applications and security. So I highlighted a green: develop internal and external software applications securely. Make sure they're in accordance with the PCI DSS, such as secure authentication and logging, based on industry standards, and incorporating information security throughout the software development lifecycle. Examine written software development process to verify they follow industry standards. So they're going to have processes that they're going to use for writing software, developing code to create an application, and all we're going to do is make sure that the process that they are following are also following industry standards. Verify security is included throughout the life cycle. There's different life cycles depending on what they're using in development. They could be using the waterfall effect. There's another one. There's several different ones. But without this, vulnerabilities can inadvertently or maliciously be introduced. So, by not securing the code or following best practices, it allows hackers to infiltrate the system easier, and that's what the standards are there to help you prevent. Now, again, these are just the base standards. If they want to go up and beyond, even better, but it's up to the company. Next one: remove development, test, or custom application accounts, user IDs, and passwords. Basically, just remove custom accounts during testing and IDs, and don't use real credit card dating while you're testing. Review custom code prior to releasing to production or customers in order to identify any potential coding vulnerability, using either manual or automated, to include at least the following: code changes, code reviews, appropriate corrections, and code review results. So make sure they identify any code changes. Make sure they review any code that is developed according to the securing code reviews. That's funny. Make sure they review the code reviews. So interesting. Appropriate corrections are implemented. Make sure you review the appropriate corrections that are implemented prior to release. Code reviews results are reviewed as and approved by management prior to release. That one kind of threw me off a little bit. They're approved by management. Most managers don't know how to they might be managing a coding team, but that doesn't mean that they know about how to code. They know how to manage, hence management. But there are some managers that will know about coding and application development and stuff, but most of them, they're just there to manage the team. That's it. Make sure they get the work done on time, make sure they're back from breaks, etc. But now, security vulnerabilities in custom code are commonly exploited by malicious individuals to gain control. Basically, reamping what I said earlier about a previous slide. Individuals must be experienced in code reviews. What that means is the people that are doing the code reviews need to be experienced and trained in code reviews. I do remember reading that they have to be annually certified or trained in it, and they have to show some kind of training that they've done to do the code reviews. Code reviews should be performed by someone other than the code writer. Automation can be used. We only select a sample of code, not the whole. So we only look at, let's say let's say they have like 40,000 lines of code. We only need to look at maybe, I don't know, 100 lines of code, maybe 50, if that, and just make sure that and also make sure that the code reviews are done by people who know about code reviews and are not the code writers. So I could create a code. To me, my code work, and I could understand this actually because I've developed and I've actually done some coding in C++, Java, and so on. And I write this code. I think it's working. It's working awesome. Well, I don't know what the security standards are. I never really did research on that. That would be done by someone else. They'll say, hey, okay, you need to include this in your code. And I was like, oh, okay, cool, I'll include it. Now, separate development test environments from production environments. Oh, separate. Basically, it's just basically saying the same thing as the last slide by separating the test environment from production environment. By reducing access to the production environment and cardholder data, reduce risks, and separate development and test functions from production. Separate development and test function from productions. The reason why you wanted to separate the development and test functions from the production environment, because the production environment, that's where all your restrictions are, your policies. You have very heavily accessed. Production and test environment, because they're so relaxed on restrictions, because we're just testing it out. That's why they don't want you to use credit card information during testing. That's the whole thing behind 6411 or 641. Now, separation of duties between development and production environments. Without adequate separation between environments, it may be possible for the production environments and cardholder data to be compromised. There's three slides so far that relate to the same thing. Okay. Production data, live pans, are not used for testing or basically what I just stated earlier. Security controls are usually not as strict in test environments as they are in production. Removal of test data and accounts from system components before. Now, I wrote very similar to 631 because it talks about removal of IDs, accounts, and passwords. This one's including removal of test data as well, including accounts. So, test data, this needs to be removed to prevent outsiders. Wow, I spelled from wrong. I put fro instead of from. Hold on. Could I change that? Nice. Boop. There we go. All right. From knowing how the system works. So the reason why you want to move the test data is because, let's say a hacker logs in and they see some code and they're like, oh, okay. And you don't want them knowing how the system works. You don't know, like let's say you're trying to get to, I don't know, McDonald's or the bank to your account number or to your box. You don't want the hacker to know what bank you're at. You don't want them to know what box you're at. But if you put down on a piece of paper how to get there and where to walk, they're going to know what bank you're at and what box you're going to pull out of your bank. So now they know more. They have a stronger feeling of what they are looking for. If I said that right. Like my mind's like, what? Change control procedures must include the following: documentation of impact, documented change approval by authorized parties, function testing to verify that the change does not adversely impact the security systems, and blackout procedures. Now, this is basically combining 645 through 6, 7, 8. Each bullet point is one. So 6, 7, 8. Now I think 4.5 through 4.9. But basically, bullet point one, sampling of system components. If not, if the system's not managed, if not managed, the impact of the system can have unintended consequences. Documented so parties can plan for changes. Legitimate and approved changes. Testing should be validated and system restored procedures. You do want to have system restored procedures in case if flooding happens, a tornado knocks down the building, lightning hits it and melts the building. Who knows? But basically, you want to document any changes, any authorizations, because if something happens, they want a breadcrumb effect trail to go back on and see who did what, why did this happen, and so forth. So basically, they're trying to find someone to blame and how to fix the issue at the same time. Now, when testing should validate controls remain in place or strengthen, what that means is when you're testing to verify changes, that when you're adding changes to a system, you want to test it to make sure it's not adversely impacting the system. Now, you want to have strong security controls and you want to meet the minimum. Now, if it ends up strengthening it, then it's okay. You're making it will change the environment, but you're changing it to strengthening it, which is a good thing. Upon completion of significant change, all relevant PCI DSS requirements must be implemented on a new or changed system and networks and documented updated as applicable. Having processes to analyze significant changes ensures that all appropriate PCI DSS controls are applied to any systems or networks added or changed within in-scope environment. This way they could keep up with, if you make a change, how was it before the change, how was it after the change, does it affect our environment heavily or lightly, stuff like that. Device inventories, so your device inventory and configurations will change during changes. So the more changes or the more devices you add, the more stuff you have to jot down. If you remove a device, document that you removed it and changes that were and any updated configuration. Maybe a configuration says block this router, but you removed that router. Why would you still have that configuration to block a router that's no longer there? That kind of stuff. New systems have a quarterly scanning process. Now, normally you would scan the system on a annual basis. That's the key word, annually. Most of these are going to be annually. However, any new systems that you introduce into the network, into the environment, has to be scanned on a quarterly basis. Address common code vulnerabilities in software development processes as follows. Train developers at least annually. Again, that word annually. Just make sure it's annually during this. Up to date. Coding techniques, including how to avoid common coding vulnerabilities. Develop applications based on secure coding guidelines. The application layer, which is layer 7 in the OSI model, is high risk and may be targeted by threats. Having staff knowledgeable of secured coding guidelines should reduce this vulnerability. Now, the OSI model, I've done networking and had a study for the Cisco certification, and the best way to know the OS model, if you're curious, apparently to know, would be all people seem to need data processing. if you know that phrase, there's this pizza one that people use too, some pepperoni pizza or whatever. I can't remember that one very well, but this one, all people seem to need data processing. All being layer 7 is the application layer. People being layer 6 being presentation layer, and so on. Injection flaws, particularly SQL injection. Also considered OS command injection, LDAP, and XPath injection flaws, as well as any other injection flaws. Basically, you want to validate the input of the user data and make sure that it does not contain brackets, @ curly brackets, and so on. Because programming requires brackets, curly brackets, and different types of things depending on what language they're using, and so on. Injections occur when user supplied data is sent to an interpreter as part of the command. Basically, let's say a system's asking for a password, and you normally use like, okay, I'll type in my password. Well, a hacker, on the other hand, could type in a line of code instead of a password, hit enter, and see what it does. If you're not validating that input, making sure that that input does not include the curly brackets, does not include the parentheses, stuff to look out for, exclamation points, the @ and so on. Except for email. Now, the email field where they ask for email, that would be an interesting concept there. But apparently, I don't think we have to worry about the email field for credit card data. For logging in purposes, anyway. Buffer overflows. Buffer overflows occur when an application does not have appropriate bounds checking on its buffer space. This can cause the information in the buffer to be pushed out of the buffer memory and code to be executed. With this think of a glass. You have a glass, and that glass is filled with halfway with water. As you're searching the web or whatnot, that glass of water will stay here, and as you go to the next page, it kind of dissipates. But a hacker, on the other hand, will inject that glass with so much water till it overflows. Once it overflows, that glass of water basically it's being checked by the system. That's why they call it a buffer, because it wants to check the code. You're checking for curly brackets. You're checking for @. You're basically like the last slide I was talking about. But if you overflow it, basically you fill it up to where it overflows. Now that code is not being validated on the one that's being spilled into the system, and it can be executed, which could give a hacker access to your system and steal credit card data. Insecure cryptic storage. Basically just encrypted data from plain text when storing on a device, computer, external, HD, USB, whatnot. Insecure communications. Basically, make sure that no credit card data is in plain text during transmitting between systems. You're sending from computer A to computer B, then or let's say I'm submitting it from one location to another over the internet. Make sure it's encrypted using VPN, and so on. Improper error handling. Applications can intentionally leak info about their configuration. Hackers can use this to create a DOS attack. This message, now the first 2 bullet points that I have is what I got, and I was like, improper error handling, and I was thinking code, like maybe they used improper code, so I was like, great, there's all about coding again. But then the 3rd bullet points actually makes a bigger impact on the other 2 bullet points. Use messages like data cannot be verified instead of password is incorrect. And I was like, oh, that's where the green light went off on, for me anyway. Let's say you're trying to log in, you type in your username and then you type in your password. Most systems will say, oh, incorrect password. Well, at that point you're like, Now I know the username is correct, right? So let's try a different password. Well, a hacker, they already know half the information now. They could type in something in the ID until it, and then type something in a password. If it doesn't mention anything wrong with the ID, then they know the ID is correct. Now, if you do incorrect, data cannot be verified, or you could also say incorrect username and slash or password in one sentence. I don't know if the user ID is correct. I don't know if the password is correct. You as the user do, but the hacker won't know. So that makes it harder for them to hack the system. That's what improper error handling entails. The errors that pop up on your computer, when you do something, it have a message saying why that error incurred, right? That's what improper error handling entails. Well, that's what error handling entails, is what I meant. Well, all high risk vulnerabilities identified. So the reason why I put that in green and not the whole sentence, because the whole thing is talking about make sure you identify high risk vulnerabilities. End of story, period, right? All high risks should be identified and addressed during application development. Crosssite scripting. Crosssite scripting occurs whenever an application takes over user-supplied data and sends it to a web browser without first validating or encoding that content. It allows attackers to execute script in the victim's browser, which can hijack the user's session, deface the websites, and possibly introduce worms, and so on. How can I sum that up here? Whenever an application takes user-supplied data and sends it to a web browser, whenever an application takes user-supplied data and sends it to a web browser without first validating. Technically it refers to, well, it's Crosssite. To execute script allows attackers to execute script in the victim's browser. Oh, okay. Let's say you're on a website and you're logged in. You're viewing your application. Let's say a bank account. You're logged into your bank. Well, a hacker can have on his computer be viewing hacked into your session as well through the web browser and seeing what you're doing, and he can make changes and stuff like that and throw injections and take credit card data. When an application takes user supplied data, so application to me, it's like a Microsoft Word, Excel, and so on. Well, I guess I'll look into that more. Like scripting. Improper access control, such as insecure direct object references. Failure to restrict URL access, directory transversal, and failure to restrict user access to functions. Basically, address coding techniques such as proper authentication of users, sanitized input. What that means, okay, hold on, let me back up a little bit. Improper access control, such as insecure direct object reference. Let's say you have a link on your website, and that link goes directly to a file. That file could be anything. It could be an Excel sheet. It could be a picture. It could be a file full of pictures. It could be a file full of documents, or Word documents, and so on. Now, you technically don't want that type of thing on your website. On a computer, it's like going to your let's see what this is called. The yellow folder on your computer called Windows Explorer can you could copy links, and you could have a link and link it to your desktop, right? You can right click, save to desktop, or save a shortcut. You know that shortcut's to desktop, right? You click it, it takes you directly to that folder, correct? Same scenario, but on a website, if you think of it in that terms. Now, you don't want that to be on the website, and you don't want anybody just to, if it leads to sensitive information, you definitely don't want anybody just to click on the link and then view everything in that folder or file or whatever you have it linked to. So you implement authentication of users. So let's say Bob logs into the site, but he's not authenticated. He won't see the links. But Sally logs in, gets authenticated, and she sees the links. Maybe you can have something like that happen, set up. Now the sanitizing of input, what that means is basically make sure that if you're asking for a password, it's just letters and numbers and a special character. You don't want you're looking for open and close brackets. Basically, you're just trying to prevent codes from being executed in an input field on a website. Not exposing internal object references to users interfaces that do not permit access to unauthorized functions. Kind of constantly enforce access to presentation layer, which is layer 6 of the OSML model. Only authorized users should be permitted to access direct options to sit. Basically, I just said all that. Crosssite request forgery. I'm gonna put your password into this field and log in and say call myself you. Yes, I'm you. A CRF attack forces a logged-on victim's browser to send a pre-authenticated request to a vulnerability web application. Access to update. This gives the hacker access update to account details. The hacker can access to make purchases and so on. This is very similar to cross-script scripting, the CSS one, right? the XSS, cross-script scripting, is very similar to this cross-site request forgery. Basically, you're logged into a web browser and it sends your data. You log in, you authentize who you are. Then once you're logged in, the hacker has access to your data. So I don't know if he's like looking at your computer or if he's logged into your computer and then waiting for you to log in and then do his thing, or you go through a website and it looks legit. This is why you have to pay attention to the URL. It looks legit. It looks just the same. And as soon as you type in your information, it kind of makes a funny, weird flashing on your screen. And you're like, oh, I guess I didn't log in, so let me try it again, right? And you do it again, you're logged in. Well, what happened was you just sent your information to some hacker that just created a page that looks like the website. But I don't know. That's called something, but I forgot what it was called. Broken authentication and session management. Flagging session tokens, cookies, as secure. Not exposing session IDs in the URL, and improper timeouts and rotation of IDs after successful logins. Cookies. Cookies are basically when you visit a web browser, if you've never visited the site before, it takes a little bit of time for it to load, correct? Depending on how far away it is, I guess. But once it loads these cookies. Well, that way, when you go back to the site, it loads up like that, and you don't even think about it. Cookies help with that. Cookies also help with um, verifying your computer, you and your location, your where you're at. If you're in Texas or if you're in California or Mexico or overseas somewhere. But improper timeouts, what that talks about is you're logged into a system, and let's say you walk away because you got to the bathroom or something. Well, you want the system to log you out if you forget to log out, especially your employees, because you don't want someone a, a walk by to see the information and then send it to their email, because now the cookies are going to show it came from your computer, your station, that you sent this guy an email and you were in the bathroom the whole time. Well, when they go back and view it, they're going to say, "Why did you send this email?" And you're like, "Well, I didn't do it." Well, the system shows it came from your computer. Can you? And then it gets a big old ordeal. So you got to make sure that stuff like that's implemented, timeouts. And you don't want the IDs to show in the URL. That's why you see the IDs either hashed or whatnot. Let's say you go to Amazon.com, you log in, it's not going to show the ID, the username that you just used to log in the URL. Six. Almost done. Almost done. This is a very long session. Okay. Public-facing web applications address new threats and vulnerabilities on an ongoing basis, and ensure these applications are protected against known attacks by either of the following: reviewing public-facing web applications via manual or automated application vulnerability security assessment tools or methods, at least annually, again that word annually, and after any changes. Now you can install an automated technical solution that detects and prevents web-based attacks. For example, a web application firewall in front of the facing web applications to continually check all traffic. Now, if you choose one, that then all vulnerabilities, it needs to be checked manually or automated with an automated application or system that you're using, and you got to review the public facing web applications annually, and if you make any changes, after any changes, and it has to be annual or manual, and you have to have someone do this constantly, annually or after any changes, either doing it manually or automated. Now, if you have a web application firewall or something similar to that, then you just make sure it's sitting in front of the public-facing web apps, and actively running and stays up to date, is generating audit logs and configured to block attacks or generate an alert that is immediately investigated. So, if you have a web application firewall, you don't have to do that manually or automated system scanning after annually or after any changes. But if you use an application firewall, you just set it up and then boom, you just let it run. You don't have to worry about the annual or anything else like that. But you do have to make sure that if it does generate an alert, that it is immediately investigated. Ensure that security policies and operating procedures are developing and maintaining secure systems and applications are documented, in use, and known to all affected parties. Basically, every requirement requires that at the very make sure everything is secured. Policies and operating procedures are developed and are maintained accordingly to all system owners. Make sure they're following. Personnel needs to be aware of the following security policies and operational procedures to ensure systems and applications are securely developed and protected from vulnerabilities on a continuous basis. By having personnel being aware and following the policy procedures, you reduce the vulnerability attacks. You reduce the attack range, the attack table, the surface. You reduce a lot. Are you going to be 100% secured? No, nobody is. But would you rather have 20 to 100 attacks a year, or maybe just you might get a attack once in a 10-year period, and all of a sudden they take only a few things and not everything? Which one sounds better? And I believe that's my last slide. Usually I have a slide that says thank you very much for watching, but I forgot to include that slide as well. Well, thanks a lot for watching, and hopefully you have a great day.